Hi everyone, this is Mr. Hall and this is a quick video about solution calculations. This is the second of 3 videos I'm going to do about how you do these kind of calculations. In today's video, what I'm going to go through is the following. I'm going to recall the equation that links concentration, volume and moles. This is what I went through in my first video. We'll calculate the concentration of the solution. Again, that's kind of from my first video, but we'll revisit it anyway very quickly. And then secondly, or thirdly rather, we're going to rearrange the equation to calculate the volume and number of moles in the solution. This is new and it's something which may be unfamiliar to you. So let's get started. So first off, I've just got 2 boxes here I want you to look at. I think my video is covering this, but you should hopefully see it reasonably well. So I've got solution 1 and this is solution 2. And you can see they're both the same size, but they've got different numbers of particles inside it. So solution 1, which is the top box, has a volume of 2 decimeter cubed and it has a concentration of 3 moles per decimeter cubed. Okay, so let's say it's got it's a volume of 2 decimeter cubed, that's how big it is, and its concentration is 3 moles per decimeter cubed. However, the second one has a concentration of 2 moles per decimeter cubed and contains 4 moles. So it has the same volume but a very, very different concentration. So the question is, how many moles are in solution 1? So in solution 1, if you count them, you can see there's 1, 2, 3, 4, 5, 6. So we've got 6 moles inside here. And in the second one, what's the volume of solution 2? This volume is 2 decimeter cubed. In terms of the number of moles, it's got 4 moles inside it. And then the big question, I guess, is how can we work out the volume and number of moles for any solution if we had to do it mathematically? Now, we know that concentration equals moles divided by volume. Okay. Now, if you look at this box, this is 2 decimeters cubed. Again, it's got 6 moles. So if I was to kind of break this up into 2, like so, then each half would be 1 decimeter cubed, and this would be 1 decimeter cubed. And if I was to kind of split this evenly, I'd have 3 moles inside here and 3 moles inside here, which would give me the concentration of 3 moles per decimeter cubed. Now over here, there are 4 moles inside it. And again, if I break it up into 2, so each one is 1 decimeter cubed, like each half of the box, this one has got 2 moles inside it, this one has got 2 moles inside it. So it's got 2 moles for every decimeter cubed. Whereas for the top one, this had 3 moles for every decimeter cubed. Now, hopefully you can kind of work out the mathematics of how to work out these numbers, because if you've got 6 moles and you've got a 2 decimeter cubed container, you can do 6 over 2, which gives you 3. And then by manipulating it, you can work out actually that if I've got a concentration of 3 moles per decimeter cubed, but I've got 2 lots of those boxes, then you can do 3 times 2, which gives you 6. And that effectively is your first equation, which is concentration multiplied by volume, and that gives you the moles. Now the other equation which you need to know, so we've done concentration, we've done moles, and then the volume. Now the volume is equal to, I've got 4 moles inside here, but I've got a concentration of 2 moles per decimeter cubed. So to work out the volume, it's simply the moles divided by the concentration. And in this case, it would be 4 divided by the concentration of 2 moles per decimeter cubed, which gives you 2 decimeter cubed. So effectively, the reason why I've gone through that is because it kind of sets up the equation that you need to know, the equation triangle. So the equation triangle that I find useful is this one. So you've got M, C, and V, and M's at the top, and you've got C and V either side. As you may be familiar with equation triangles, if they're next to each other, it's a multiply. If one's on top of the other, then it's simply divide. Okay, so moles is at the top here, and just remember that 1 mole is equal to 6.022 times 10 to the 23 of anything. It's usually molecules, but it can sometimes be atoms or whatever. The C here is concentration, the unit is always moles per decimeter cubed, and then the V is volume, the unit is decimeter cubed. This may often need converting, so just remember that 1 litre is the same as 1 decimeter cubed, which is 1,000 centimeter cubed. So to derive the equations, moles will equal, if you just cover it, you'll know that it's going to be C multiplied by V, or concentration multiplied by volume. Here, concentration will equal M divided by V. And over here, the volume equals moles divided by concentration. So remembering this is very, very useful. The way I remember it is I always remember that concentration's unit is moles per decimeter cubed. So if you think about here, concentration is moles divided by decimeter cubed. And that's how I remember the equation from the unit. And then if I know moles is at the top of the triangle, then the C and V must be at the bottom. It doesn't really matter the order they're in as long as they're at the bottom. So let's have a practice at this. So the first question, it says 2 moles of sodium hydroxide are used to make 500 centimeter cubed of solution. What is the concentration? The first thing I always do is I do my conversions of units. So I've got 500 centimeter cubed here. And I know that I always have to do these calculations in decimeter cubed. So I'm going to have to divide this by 1,000 to get decimeter cubed, which is 0.5 decimeter cubed. I then need to work out my equation. Now remember, my triangle, moles is always at the top, and I've got C and V. Now I'm working out concentration. So from this, concentration equals moles divided by volume. Now that's the first thing I write. So concentration equals moles divided by volume. Okay, now my moles is 2, so I put 2 there. And then my volume, now it says 500, but remember the conversion, so it's 2 divided by 0.5. And then 2 divided by 0.5 is pretty much timesing it by 2, which is 4. And then the unit is mole per decimeter cubed. Okay, so that's my first example. Let's try a couple more. So for my next one, it says calculate the moles of hydrochloric acid needed to make up 400 centimeter cubed with a concentration of 0.25. Now the first thing I do is I do my conversion. I've got 400 centimeter cubed. I want that in decimeter cubed, so I have to divide that by 1,000. And that gives me 0.4 decimeter cubed. The next bit now is to work out my equation. So if I look at my triangle again, it ends at the top all the time. I'm working out moles here. Now because moles is at the top, these have to multiply, so it's concentration multiplied by volume. So my moles, I'll write this out again, and please do the same if you're doing an example. It's concentration multiplied by volume. Now my concentration is 0.25. And I multiply that by the volume, which is 0.4. Remember, I've got to do decimeter cubed. So 0.25 times 0.4. I think it's 0.1. I'm just going to double check it so I don't make an error. Yep, it's 0.1. So therefore, it's 0.1. Now, because I'm working out moles, I'm just going to write 0.1 moles. Okay, and that's fine. And that's it for that. Let's try one more. So here it says calculate the volume of sodium hydroxide made up if 0.645 moles of the solid makes up a solution with a concentration of 0.600 moles per decimeter cubed. Now the first thing I'm going to do is I'm going to maybe not do it there, let's do it here. I'm going to do my equation triangle. So it's moles, concentration, and volume. Now I'm working out volume. So volume equals moles divided by concentration. So I'm going to write that down here. So volume equals moles divided by concentration. And again, writing this out at the start is really important. Now my moles is 0.645, as you can see here. My concentration is this number, 0.600. So I put that in my calculator. So what's that? 0.645 over 0.6 gives me 1.075 decimeter cubed. Now you might sometimes be asked to put your answer in centimeter cubed, and if you have to do that, you just have to multiply it by 1,000. So 1.075 times 1,000, and that gives you 1075 centimeter cubed. If you've been really fancy, you'll notice that all our information is to 3 significant figures. So if I wanted to round this to 3 significant figures, it would be 1080 centimeter cubed to 3 SF. And that's it. So I hope that's been useful, and best of luck with your solution calculations.